So this year is our lower 6th term 1 physics project. Our group members include Avinash Deosaran, Danielle Tannis, and Samuel Rogers. We decided to investigate an object in freefall, and it's important to note that objects in freefall are influenced only by the downward force of gravity. They accelerate towards the Earth at a speed of 9.81 meters per second squared, which is usually rounded off to 10 meters per second squared. It is also important to note that objects in freefall experience no substantial or significant amount of drag or air resistance. We decided that Newton's first law, which as you can see here, could have been applied to objects in freefall. What you see in here is exactly what Sir Isaac Newton said, and what it basically says is that if a body is at rest, it remains at rest, or if it is in motion, it moves with uniform velocity, examples constant speed in a straight line, until it is acted upon by a resultant force. So when the ball is being held, it is at rest, therefore the airspeed is 0, but when it is released, the object accelerates. Why? Because it is being acted upon by an unbalanced force, which is gravity. But when the drag is equal to weight, this is when the object no longer accelerates but holds a constant velocity, also known as terminal velocity. So basically this is the video recorded. It is a ball falling. Release started from rest, release and falling a distance of 1.45 centimeters, 145 centimeters, 1.45 meters. As you can see, I already set up the axes and the scale. So just give you an idea what it looks like. So now I'm going to track the ball as it moves along the scale. So I created a point mass, and then I located the search area. I zoomed in so that I get a more specific area, and then I selected the object. I adjusted the shape, and then I put the pointer exactly beneath the wind ball, and I extended the searching scope. So I zoomed out, to about zoom to fit, and then extended the searching. Move it into position, and then I tracked it. Good. So that was basically what I did to get the graph I got. So that is basically it, and this is the graph I got. As you can see, it is a curve, and it is a distance time graph. At this present state here, it indicates that the ball is decreasing in acceleration, so it is decelerating, which is actually incorrect due to the fact that the object is supposed to be accelerated. This actually indicates that the velocity is decreasing, which is also incorrect because the velocity is increasing as the distance increases, since it is accelerated. So further analysis of the graph indicates that the slope is negative because the actual actual gradient is negative 3.089, which is obviously incorrect. It is supposed to be positive, and the y-intercept is 1.230, which is supposed to be the origin by itself, but because of the way the axes were set up, it gave this value, which is obviously incorrect. But I inputted this image later, and this is what it should basically look like. This is what it should look like. So as you can see here in this diagram, don't mind the labeling, but in this diagram you can see that the graph is supposed will indicate, if since this is a distance time graph, it will indicate that the object is accelerating and the velocity is increasing. So as you can see, the slope will therefore be positive. So that's basically it. After analyzing the video of the windwall falling, is what I got, which as I said before, is not accurate.